Have you ever looked up at the night sky and wondered about the stars? They seem like tiny, glittering points of light, but they are so much more. Each one is a sun. A massive ball of glowing gas, incredibly far away. One of these stars is particularly special to us. It's called Proxima Centauri. Proxima, meaning nearest in Latin, the closest star to our sun, a cosmic neighbor across an incomprehensibly vast expanse of space, a constant source of curiosity for astronomers and dreamers, a tantalizing destination just beyond our reach. For centuries, humanity has gazed at the cosmos. We've sent probes to planets in our solar system, but the stars have remained distant dreams. Proxima Centauri becomes the first star we think about visiting. What would it be like? So, let's begin this grand imaginary adventure into the fires of our nearest stellar neighbor. The first thing we must comprehend on our journey is distance. The distances in space are simply staggering, far beyond anything we can relate to in our daily lives. Proxima Centauri is about 4.2 light-years away. That sounds simple enough, but a light-year is the distance light travels in 1 year, which is nearly 10 trillion kilometers. So, our destination is over 40 trillion kilometers from Earth. To put that into perspective, the fastest spacecraft ever launched by humans would take tens of thousands of years to cover that distance. Our journey, therefore, must be one of the imagination, a mental leap across the void. Let's imagine we have a fantastical spacecraft, one that can travel at nearly the speed of light, folding space and time to bring us to our destination. As we leave our solar system behind, the sun shrinks to become the brightest star in the sky, then just one among countless others. The journey would be long and dark, with the constellations shifting around us as we move through the galaxy. We are crossing an empty chasm between suns, a region of near-perfect vacuum, cold and silent. For years we would travel with the faint reddish dot of Proxima Centauri slowly growing brighter in our viewports. Finally, after our long voyage, we would arrive. The Alpha Centauri system would dominate the view. But our target is their dim companion Proxima Centauri. It wouldn't look like our sun. Instead, it would appear as a deep, angry red orb, much smaller and fainter. It's a red dwarf. Red dwarfs are the most common stars in the Milky Way, but so small and dim we can't see them from Earth. Proxima Centauri has only about 1/8 the mass of our sun and is much smaller and cooler. What makes a star and not a planet? The answer? Nuclear fusion. At a star's core, the pressure and temperature are insanely high, crushing atoms together. Lighter elements like hydrogen fuse into heavier elements like helium. That fusion releases huge energy as light and heat. This energy pushes outward against gravity, keeping the star stable for billions or even trillions of years. Proxima Centauri burns fuel much more slowly and at a lower temperature than our sun. Red dwarfs can be violent too. They are flare stars, able to suddenly erupt with bursts of energy and radiation. Now, our fall accelerates. We cross the point of no return. As we get closer, the first thing we would notice is the overwhelming light and heat. Even though Proxima Centauri is cooler than the sun, cool is a relative term. The temperature rises to thousands of degrees Celsius. Our imaginary spaceship would not simply melt, it would vaporize. And honestly, our own body would not simply melt, it would vaporize. Every solid material would turn directly into gas. The light would be blindingly intense, a sea of red that would overwhelm any sensors or eyes. The next force to contend with is gravity. Proxima Centauri is less massive than the sun, but it is also much denser. As you fall, the gravitational pull would become immense. You would experience something called tidal forces. The part of your body closer to the star would be pulled much more strongly than the part farther away. This difference in gravitational pull would stretch you out, a process gruesomely nicknamed spaghettification. Your body would be elongated into a thin stream of atoms. You would cease to be a person and become a ribbon of matter. Let's imagine you could somehow survive the heat and tidal forces. What would you touch? A star doesn't have a solid surface like a planet. It has a photosphere, which is the visible surface we see. It's a layer of dense, glowing gas. Below the photosphere, the journey continues into the star's interior. Here, the pressure and temperature climb to millions of degrees. You are now just a collection of atoms, stripped of your electrons, becoming part of the plasma of the star itself. You would be swept along in massive convection currents, giant rolling flows of hot gas rising from the core and cool gas sinking from the surface. Deep inside Proxima Centauri and its core, the conditions are unimaginable. The pressure is billions of times greater than on Earth and the temperature is millions of degrees. Atoms that once made up our imaginary traveler would be subjected to nuclear fusion. Hydrogen nuclei from the water in your body would be stripped bare, then slammed together with other nuclei to form helium. You would become fuel for the star, your matter converted into the energy that makes it shine. It's the most complete form of recycling in the universe. This thought experiment makes one thing clear: falling into a star is not survivable. There's no technology we can imagine that could protect a person from such extreme forces. Intense heat, overwhelming radiation, crushing gravity, extreme pressures. We are beings made for the gentle, stable environment of a planet's surface. Stars operate on a different level of physics, fundamentally hostile to life as we know it. They are the givers of life, but only from a great distance. When we compare Proxima Centauri to our Sun, we see both similarities and differences. Both are fusion-powered, providing light and warmth. Our Sun is much larger, hotter, brighter. Our Sun will burn out in another 5 billion years. Proxima Centauri will continue to glow for trillions of years, long after our galaxy has changed beyond recognition. In the end, stars like Proxima Centauri represent the profound duality of the cosmos, safe on our small blue world looking out at the cosmic fires from a respectful distance.